If you had told me like 15 years ago that I would one day be using this Calvin and Hobbes to illustrate math concepts and computer graphics, I probably would have just assumed you were pulling my nose. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's start blurring the line between 2D and 3D. So the basic characteristics of a perspective camera projection are somewhat indirectly described in this comic strip. Parallel lines start to converge towards the horizon, points that are farther away from the camera's eye start to end up somewhere towards the center of the screen. The consequences of this in normal English are that if something is far away from you, it's going to appear smaller. However, that is not the only kind of camera projection that you can use. There is a different camera projection, and in some ways you might consider it the opposite camera projection, which is the orthographic camera. And not knowing anything else about it, just from the name alone, you can probably start to imagine how this is going to work. Ortho meaning same, and graph meaning right. 2 points that are the same distance away from each other, when projected onto the screen, are going to still be the same distance away from each other, no matter how far away they are, how close or near they are to the camera. One can certainly imagine the problems that this would cause for Calvin should his eyes just magically start interpreting the world this way. Whether or not you've been aware of the name for them, these are absolutely something that you all have seen before. And I'm not just talking about 2.5D games like the modern 2D Mario, or Rayman or whatever. I am talking about the camera projection used by default in pretty much every 2D game made since the advent of the graphics card.
Hey.
Orthographic cameras are just the fancy word for a 2D projection. So, I have on the screen in front of me a little 3D test world. We've got a little ball that's serving as the player that I can move around with the mouse keys. We've got some basic things on the scene. There are some trees, there are some, there's this pirate ship that I've been using for the last couple of weeks to demonstrate this, that, and the other thing. This is a basic 3D scene. It is nothing that you have not seen before if you have been watching these videos for any length of time. So if I were to close the game and go into the camera's draw event so that we can see how this is working, this is pretty much as to be expected. We have a view matrix, which is matrix build look at from one position to another. We have the projection matrix, which is a perspective projection defined by a field of view, an aspect ratio, and 2 clipping planes. Then we're going and drawing all of the stuff in the world, which is just drawing the floor, the pirate ship, the trees, whatever. As far as the projection matrix goes, because this is what we're interested in today, we have matrix build projection perspective FOV. There are 2 other functions in GameMaker which you can use to define a projection matrix. One is just matrix build projection perspective, which is also going to give you a perspective camera, but it is going to define it in a slightly different way. And the other is matrix build projection ortho. And you can see down at the bottom of the screen that this takes 4 arguments. 2 of them look familiar, they're just the clipping planes. The other 2 are width and height, and we might as well start off by just entering the width of the camera's viewport into this function, and that in this case will be the sides of the game window. So we can say window get width. For the width, the height can be window get height. Z near and Z far, like I said, those are just the clipping planes. I've talked about the clipping planes in the past. Anything closer to the camera than the near clipping plane will not be drawn. Anything farther away than the far clipping plane will not be drawn. Let's make that Z near and Z far, same as with the perspective projection. I can comment out this line. It does not need to run. It is not used. And now when I run the game, we're going to see that things look slightly different. First thing that you will notice is that everything is upside down. The second thing that you will notice is that this suddenly looks a lot like a 2D game. We no longer really have a sense of depth except for which objects are literally in front of other objects. There's no real sense of perspective here. If you look at the square trees, you can see that we're facing them head on. You can't see the sides of them or anything like that, especially the trees that are all the way off to the side of the screen. You would expect over here the cubes that are all the way off to the side, if you had a perspective camera, that you would be able to see the sides of the faces of the trees, but that is not the case. Possibly most obviously, the floor appears to be gone, and that is not because the floor is not being drawn. The floor is indeed being drawn, but it is being drawn perfectly perpendicular to the camera, meaning that no pixels on the screen are actually filled by it, because the floor is just a plane that's infinitely thin, and we're viewing it from a perfectly side-on angle. So let's start to pick this apart a little bit. So firstly, if we wanted to make the screen not upside down, you remember how I did this stupid hack in the early days of this 3D and GameMaker series where I just made the field of view negative and the aspect ratio negative? Well, we're going to do a similarly stupid hack just to make the world appear right side up, and that is just going to be to throw a negative sign in front of the window get height term in the orthographic camera definition. This boils down to the fact that GameMaker and I have some fundamental disagreements on what constitutes the definition of up in a coordinate system. The argument over whether positive y or positive z or sometimes negative y should be defined as up in a 3D camera system. There are valid reasons to want to do each of those things. So you can see now that the world is right side up, but we still have essentially a 2D camera projection. These trees are still being viewed perfectly head-on. The pirate ship, despite being farther away than things like the trees in the foreground, is still approximately the same size. It has not diminished in size despite being farther away. We still can't see the floor, and again, that is because the floor is perfectly perpendicular to our looking direction, and it does not actually resolve to any pixels on the screen, because it's a flat sheet. That's something that can still happen with a perspective camera in 3D, by the way. It's just something that's easier to do by accident with an orthographic projection. So, let's start playing with this. First, if we want to actually be able to see the floor, which I think will go a long way when it comes to helping us figure out our position in space, it might help if we were to look down at it slightly, and if we were to not look at it at a head-on angle. So if I were to set z from to 100 and z2 to, for example, 0, we'll be looking down on the scene slightly, and we will be able to see not only the floor, but also the tops of some surfaces. And this might help us actually see the scene a little bit better. I will warn you, if you are, shall we say, not sure what to expect, this can be a little bit of a vertigo trip. It can be slightly dizzying, especially if you try to do it with something like a first-person camera. Please don't do that. Now you can see the floor, and in particular on the floor, you can see the checkerboard pattern. All of the lines horizontally, no, that's vertically. All of the lines vertically on this checkerboard pattern on the floor are now perfectly parallel, and they do not get closer together towards the horizon. Again, that's something that is a trait of a perspective projection. You can see slightly more of the tops of surfaces. You can see a little bit of the tops of these trees. You can see the top of the deck of the Going Merry. If I were to maybe make this a little bit easier, let us raise the camera a little bit more so that we're looking a little bit more down on it. There, that's a little bit easier of an overhead view. So what we have now is essentially a 2D projection. Now, there's a couple things you can do with this. First, I'm going to play with the size, the height, and the width. If I were to cut the window get width in half, for example, and also cut the window get height in half, for example, we are not going to be any closer to the scene, but we will be zoomed in a little bit. And that may actually be a little bit too zoomed in because it cuts out most of the scene. In fact, I have a better idea. Instead of hard-coding the x from, y from, z from, let me actually have this follow the player. So x from can be player x, x2 can also be player x. I got rid of the player object. The player is just two x and y coordinates now. Y from can be player y, let's say plus 400 or so. Y2 can be player Y, and now when I run the game, we should be actually following the player around with our camera. Okay, so we can move around, and this looks a lot like a regular 2D projection. We just happen to be using 3D models instead of flat sprites. So, whereas the field of view is the main important factor in how zoomed in a perspective projection appears to be, when you're dealing with an orthographic projection, the main factor in how zoomed in it appears to be, and how big it is, that's simply the width and the height. If you want to, you can define matrix build projection perspective. If you want to define a perspective projection with simply a width and a height rather than a field of view and an aspect ratio, you can. I prefer not to think about perspective projections that way. I think thinking about them in terms of the field of view and aspect ratio is easier. The way z near and z far work, the clipping planes of the perspective projection and the orthographic projection work, this is exactly the same. Like I said earlier, anything farther away than z far will not be rendered, anything nearer than z near will not be rendered. In fact, if you turned off, GPU set z test enable to false, and if you turned GPU set z right enable also to false, this would effectively become indistinguishable from a regular 2D game in GameMaker. Now, not only are we using a 2D orthographic camera, I shouldn't really call it a 2D camera, should I? Anyway, depth will also not be accounted for, so anything that is drawn later in the draw event will always be drawn over anything that is drawn previously, regardless of whether or not it should be farther away. You can see the player's sphere is drawn last in the draw event, and it is being drawn on top of anything that it tries to walk over. You can also see some fun layering issues in the order that some things like the faces on this tree trunk are being drawn. I'm sure that if I moved over to the pirate ship, we'd have all kinds of fun depth shenanigans. Yeah. Let's try not to look at that for too long. The only real significant difference between a 2D game and a 3D game, not only in GameMaker, but also just in general, is the projection that you're using, so perspective versus an orthographic projection, and whether or not you're using depth testing. But some of the fun things that you can do with that might be a story for another time. Let's see. So there's a couple things that you can do with this in games. If you've ever tried to do 3D in GameMaker prior to GameMaker Studio 1, you have most likely used an orthographic camera projection to try to draw the UI, because before, in the GameMaker 8 days and previously, we did not have access to the Draw GUI event. So if you wanted to draw an overlay on a 3D scene, you had to set the orthographic projection yourself. If you've ever tried to make an isometric game in GameMaker and you've tried to do depth testing, using the good old depth equals negative y trick, you have probably very quickly started to not have a very good time. Depth equals negative y is fine for a lot of things and it works for a lot of games, but when you try to bring it into an isometric game, it really just becomes another word for pain. But if you're to instead perhaps take control over the camera's matrices yourself and draw using some actual 3D objects, and if you were to perhaps tilt the camera around the player by, let's say, 45 degrees, you would suddenly find that you have something resembling an orthographic point of view, and you really do not have to worry any longer about depth sorting. In fact, if you're trying to make an isometric game in GameMaker, it is very often easier to simply do this, use the depth buffer, use a 3D game, use a 3D projection, than it is to actually try and do an isometric camera and I'm doing air quotes with my fingers here, normal 2D. To be fair, there are some things that GameMaker could, and some have argued should be doing to make isometric games just easier so that you don't have to do this, but isometric games were never really my thing. I was never really a fan of these kinds of projections. I know they used to be all the rage back in like the Super Nintendo days, but they never really did anything for me. So, and I'm going to just, I'm just going to make this a head-on perspective again. Alright, there we go. I feel like this is a little bit too, the camera's a little bit too high in the air. I feel like I should maybe, like, lower this a little bit. Alright, that's a little better. I'm going to do one more thing in this video, and that is going to be bringing an isometric camera projection into an existing 3D game that was designed around 3D. So first, I need to apparently open GitHub Desktop, because apparently that was not open before I started recording. And I'm going to go create myself, spawn another IDE, and I am going to go open the tower defense game that I spent a lot of time in the last year and change writing. So this is Bombardier, this is the tower defense game. If you want to see 60 and change videos on this being made, I will have a link to that playlist in the video description. This is a 3D camera. This actually uses a lot of the same tree models that I had in the demo for the orthographic camera demo earlier in the video. As you can see, this is a regular 3D projection. Things that are farther away converge. They get smaller. The parallel lines converge. If, however, I wanted to not have that be the case, I could go into the code, and I could effectively turn this into a 2D game. And, where are we? This is where the camera's matrices are set. If I were to make the font a little bit bigger, and if I were to instead define the projection matrix as matrix build projection ortho, I could give it a width of window get width. I could give it a height of window get height. I want that to be negative because I don't want the world to be upside down. And I could run the game again, and you would be able to see we have something that looks a lot more 2D, and we also have the bottom part of the world being cut off because that is, like, the size of the camera. Goes below the floor. That's fun. So if I were to start the game, we can see that we now have something that looks a lot flatter, a lot more 2D. It's still a little bit zoomed out because I guess it might be beneficial to divide this in two to zoom in a little bit, as it were. The area that you can see through an orthographic camera would be more defined by something like a block rather than a frustrum, which is like a pyramid with its tops chopped off. Okay, now we have a 2D game. If you actually wanted to, you could more or less play this way. Nope, apparently you can't, because the mouse casting, the mouse being projected into the screen isn't quite right. That's okay. Anyway, this is how we can turn a 3D game into a 2D game. I am going to bring the perspective projection back. I'm going to leave in the ortho camera just as a comment, just in case anybody's looking at the repository in the future and is interested in seeing what it looks like if you uncomment it. Anyway, it's back. We have a perspective camera. Again, if you want to see that video being made, links in the video description. So that's going to be it for orthographic cameras. There are a number of things that you can do with this, including but not limited to using both ortho and perspective projections at the same time in the same game. You could even have a camera that is somewhere in between a perspective and an orthographic projection. I have joked on numerous occasions in the past about making a Super Paper Mario fan game. And for those of you who do not know, that game's main gimmick involves flipping between 2D and 3D. And the way that you would do that would be by smoothly transitioning between a perspective and an orthographic projection. The next 3D in GameMaker that I want to make is going to be shadow mapping, and we are going to see orthographic projections coming into play in there, although somewhat indirectly. I should mention, and you may have actually picked up on this earlier, but the orthographic camera, normally in 2D games, the orthographic camera would simply be aligned to an axis. It would be aligned to, like, the XYZ coordinate system. But that does not necessarily have to be the case. You could have an orthographic camera projection pointing in any direction that you like, just the same way that you can have a perspective camera pointing in any which way that you like. I would not recommend going overboard with that. If you try to, for example, have a first-person game and you try to drop in an orthographic camera, you are perfectly free to do that. The game will work. That is probably the most surefire way that I can think of making all your players throw up, so do it at your own risk. Anyway, if you want the code for this, look for the GitHub repository down in the video description. If you want the code for the tower defense game that I was using to demo a minute ago, where is it? I have way too many repositories on my computer. You can also find the link to that in the description of this video. My name is Michael. I like wizards and dragons and making games. I try to post about 2 game dev videos a week, specifically focused on the weirder things that you can do in GameMaker, including but not limited to 3D stuff and weird shader things. I have a Patreon, so if you want to contribute towards all of these videos being made, you can find links to that in all the usual places. You could see your name in the credits, hear yourself shouted out at the end. You could see a bit of a preview of my future plans, that kind of thing. Otherwise, I hope you all found that useful, and I will see you all later. Special thanks to Edward Holt, Emily Koyo, Gunnar Clovis, Poshar, Sindra Larson, Squarecrow, Tusk, and Zenjamin for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end like this, head on over to the Patreon page down in the video description to join the fun.